The To-Do or Teamwork Makes the Dream Work is a project of the SciTech Mathematical Society, the official mathematics club of Santa Rosa Science and Technology High School. It is a project that aims to provide support to high school students in their respective mathematics subjects. This project consists of distribution of reviewers by grade level and posting of tutorial videos on YouTube. The topics in the tutorial videos are those that are requested by the SciTech students that responded in a survey given by the club, while the topic in the reviewers covers all the topics discussed in the quarter. The reviewers are only exclusive for the SciTech Mathematical Society club members.
Hello to everyone, welcome back to another SMS Project to Do Teamwork Makes the Dream Work YouTube tutorial video. I am Jasmine Pacete, SMS Grade 9 representative, and for today's video, we will be discussing about another requested topic by my batchmates, which is special parallelogram rhombus. But before we head to this main discussion, if you haven't seen our first geometry 9 discussion, which is about parallelogram and you need help on that too, do watch it first because there will be terms and stuff from that topic that we'll be using here. And yeah, with that, let's get on with our discussion. Here is our objective for today's discussion. That is to be able to prove theorems of special parallelogram rhombus. Okay? Now, first let's know what is rhombus. A rhombus is a special type of parallelogram where all the sides are congruent. Very simple. So I do hope you remember this. And so moving on. Here are the theorems on rhombus which will help us achieve our objective for today. So please do take note of them. With theorem 1 stating diagonals of rhombus are perpendicular and theorem 2 stating each diagonal of a rhombus bisects opposite angles. And with that, we'll go straight to our exercises. So get your pens and paper and let's proceed to our problem number 1. Here we have given that palm is a rhombus, prove that palm is also a parallelogram. That is, prove that the opposite sides are parallel and do not use the fact that a rhombus is a special type of parallelogram. Then complete the table below. Okay, so for this, I'm going to state first our given informations, which is for reason 1, we are given. Then for second, we have statement 2, PA is congruent to LM and AL is congruent to PM. Then reason 3 is reflexive property and SSS Moore's postulate for reason 4. And then statement 5 saying angle APL and angle MLP are alternate interior angles. Then reason 6, corresponding parts of congruent triangles are congruent. Then statement 7, PL is transversal to lines PA and LM. And statement 8, which is AL is parallel to PM and PA is parallel to LM. And lastly, to wrap it up, we have definition of parallelogram for reason number 1. Okay, so for this, to fill our statement number 1, we analyze the statement here above where the givens are stated. Then we'll have palm is a rhombus for statement number 1 because as its reason, it is a given. Okay, then on to statement number 2, which I think is derived from statement 1. That is, if palm is a rhombus, then PA is congruent to LM and AL is congruent to PM. And this is by the definition of rhombus. Okay, if you remember the definition I gave earlier. So therefore, for our reason 2, we'll have definition of rhombus. Then next, we have reflexive property as reason, and to fill up our statement from statement 2, I think we'll have if PA is congruent to LM and AL is congruent to PM, then to have a reflexive property of equality statement, that is PL is congruent to PL, which means we'll have PL is congruent to PL for our statement number 3. And next we have reason number 4, SSS congruence postulate. Okay, for this we'll derive from statement 1, 2, and 3. That is, if palm is a rhombus and PA is congruent to LM and AL is congruent to PM and PL is congruent to PL, then triangle PAL is congruent to triangle LMP, which is by the SSS congruence postulate. Therefore, now we have our statement 4, that is triangle PAL is congruent to triangle LMP. Okay, the next we are given statement number 5, which says angle ALP and angle MLP are alternate interior angles. Okay, so for this, I think we've learned the interior and exterior angles information back in 7th grade. So if we go back to that, statement 5 will be by the definition of alternate interior angles. And so therefore, we have definition of alternate interior angles to reason statement number 5. Okay? Now, next, we'll have corresponding parts of congruent triangles are congruent for our reason number 6. Okay. So for this, we'll have statement 2, 3, and 5, I think, which is if PA is congruent to LM and AL is congruent to PM, and if PL is congruent to PL and angle APL and angle MLP are alternate interior angles, then to find the corresponding parts of congruent triangles are congruent, we only have one, and that is statement angle angle APL and angle MLP are congruent. Okay, so therefore, for statement 6, we'll have angle APL is congruent to angle MLP. Reason corresponding parts of congruent triangles are congruent. Okay, the next we have statement 7. That states PL is transversal to lines PA and LM, which I think is from statement 2 and 3. If PA is congruent to LM and PL is congruent to PL, then PL is transversal to lines PA and LM. That's by the definition of transversal lines, which means we have definition of transversal lines for reason number 7. The next, we are given statement 8, which is AL is parallel to PM and PA is parallel to LM, which I think is from statement 5 and 7. That gives us if angle APL and angle MLP are alternate interior angles and PL is transversal to lines PA and LM, then AL is parallel to PM and the PA is parallel to LM, which is by the theorem if two lines are cut by a transversal, so the alternate interior angles are congruent, then the lines are parallel. Meaning, for our reason 8, we'll have transversal alternate interior angles are congruent, then lines are parallel. Okay? And now on to our last information. Given reason 9 definition of parallelogram. This is, I think, simple because definition of parallelogram. We'll just have to analyze all our formed information from 1 to 8. then we can conclude that in statement 9 we'll have palm is a parallelogram. And there we go, problem 1 solved. Now, let's move on to problem number 2. Okay, for our second problem, we have in rhombus RSTU, prove that triangle RST is isosceles. Use the statement reasons table or feel free to write a proof in paragraph form. Okay, so for this, you can create a statement reasons table, but I just wrote it in paragraph form because for me it's easier and faster to be able to express my reasonings. And so to answer, I started with giving the definition of an isosceles triangle, which is an isosceles triangle is a triangle that has two sides and angles that are equal. Then I formed new statements from given RSTU is rhombus, which is as stated there. In rhombus RSTU, RT is congruent to SU by the parallelogram property 4. Okay, we can apply the parallelogram property for this because rhombus is a special type of parallelogram. So it's still a parallelogram but a special type. Okay, so going back, since RSTU is a rhombus, then we can also say RT is congruent to SU. Thus, RT bisects angle URS and angle UTS by the definition of bisector. Okay, then from that, we can form if RS is equal to ST, then summing it up, we can therefore conclude that RST is indeed isosceles triangle. Okay, then now problem solved. On to our next problem. There, in problem number 3, we have here in rhombus sure with n as its midpoint, prove that SR is perpendicular to UE and SR bisects UE. Okay, as what I said before, there are different ways on the way a statement reason table flows. So you may have a different list here, but this is what I got. So I'm going to explain it to you, which is for statement number 1, I wrote there sure is a rhombus, which is a given. And then from statement 1, I formed statement 2, that is SU is congruent to RE and UR is congruent to SE by the definition of rhombus. Then from statement 2, I formed statement 3, which is SR is congruent to SR by the reflexive property of equality. Then for statement 4, derived from statement 2 and 3, I got SR bisects UE, reason definition of bisector. Then from statement 2 and 3, I formed statement 5, saying triangle SUR is congruent to triangle RES, which is a SSS congruence postulate. The next for statement 6, coming from statement 2 and 4, I got the definition of midpoint, which is Sn is congruent to Rn and En is congruent to Un. And then now per forming statement 7 from 2, 4, and 6, I got angle SUR is congruent to angle RES by the CPCTC. And from that, statement 7, I got statement 8, which is angle SUR and angle RES by the congruent supplementary angles or right angles. And then to wrap it up by merging all formed information, I concluded SR is perpendicular to UE with reason perpendicular lines meet to form angles. And there we have it. Problem 3 solved. Now, on to our next problem. We have here in rhombus what the measurement of angle WHT is equal to 53 degrees. Then what is the measurement of angle HAW? Okay. Well, there are multiple ways to obtain the measurement of angle HAW, but we will do what I think is faster. Okay. So since what is a rhombus? The diagonals must bisect its interior angles. Hence, HT bisects angle WHA. Therefore, the measurement of angle WHT will be equal to the measurement of angle AHT, which is equal to 53 degrees. So then, we let X be the intersection of diagonals HT and WA. Then we'll have the diagonals are perpendicular. So triangle HXA is a right triangle with right angle HXA. HXA. Hence, the measurement of angle HAX will be equal to 90 degrees and the measurement of angle AHX is also 90 degrees. Then we also apply this to the measurement of angle AHT that will be equal to 90 degrees. Then subtract that to 53 degrees to get the measurement of angle HAW, and that will be equal to 37 degrees. And there we have it, problem 4 solved. Now, on to our last problem for today. For this, we have Alanis cuts rhombus glove through its diagonals. She then notices four congruent right triangles. She then rearranges them to form a rectangle. She noticed that the longer side is longer than the longer side of the other rectangle that can be formed. So she then gave the rectangle to Neil and asked him to measure the longer side of the rectangle. And then if the longer diagonal of love is 16, then what is the length of the longer side of the formed rectangle? Okay. So for our answer, we have here the two rectangles that can be formed using the four congruent triangles in rhombus. So if we analyze the problem, the measure of the longer side of the longer rectangle would be precisely the measure of the longer diagonal of the rhombus. Hence, the answer is 16. Okay? And there we have it. Problem solved. And that's it. Thank you so much for watching. I hope you learned something and see you on our next discussion.